So, in the last module, we went on to simplify the energy equation based on the similarity variables that were defined. We came up to the form where we wrote the expressions for u d theta by dx, v d theta by dy, the extra term which was there because of the variable wall temperature. We also had the right hand side alpha d squared theta by dy squared and the viscous dissipation term which looked like this. This was done for a case, remember, T wall is a function of x and viscous dissipation present. Viscous dissipation was present. So, we took the general case and then we will simplify all this, come together to the final form which will be a general expression, and then we will come out with conditions that must be satisfied for similarity to be valid. So, having done this, now we will put all these things together. So, left hand side is these three terms, right hand side is this one and this one, because that was my simplified energy equation. A simplified energy equation was this: u d theta by dx plus v d theta by dy. I have expressions for this. U theta by g dg by dx, we retain it as it is. Alpha d square theta by dy squared, I have an expression for that here. Nu Cp delta t du by dy the whole square, that is simplified to this term. So, all now we are going to do is do very good bookkeeping of the terms. So, let us put these together, putting terms together. We get left hand side minus eta u infinity by 2x f prime. I am going to drop off this bracket eta for theta and f because it is easier to write that way. So, f prime theta prime with a minus sign. The v d theta by dy I am going to open. This is going to be written as minus f prime theta prime n of x. What was n of x? So, we had written n of x earlier. So, let us go back to the expression for n of x. We go back to the equation. N of x was, so n of x u infinity nu x under root. This was my n of x. So, v d theta by dy is f theta prime n of x eta, there is minus of minus would become plus, because if you just look at this expression, so you have a minus here and a minus here. So, I am just opening this bracket. So, minus of minus would become plus. Eta is y u infinity by nu x here divided by 2x as it is. Theta was taken, this one is left. So, another u infinity by nu x. This is the first term. The second term is now going to be minus f of eta theta prime of eta u infinity by nu x as it is dn by dx. This was my definition of v nx. This is my left hand side. Right hand side is nothing but alpha u infinity by nu x theta double prime plus the Eckert number term 2 u infinity local Eckert number over x f double prime of eta the whole square. Sorry, I said I would drop off the etas, but I wrote it in some places just out of habit. But anyway, so now we will simplify this. So, this therefore, you get minus eta u infinity by 2x f prime theta prime. Okay, I can write this as f prime theta prime nx is u infinity nu x by 2x y u infinity by nu x as it is minus f theta prime under root u infinity by nu x d eta dn by dx. What is dn by dx? This is going to be, just let us retain it as it is for now. Right hand side is alpha u infinity by nu x theta double prime plus 2u infinity local Eckert number divided by x f double prime of eta the whole square. So this, let us manipulate on this term, this one. So this one is f theta over 2x, f prime theta prime over 2x, u infinity nu x under root y u infinity by nu x, u infinity by nu x. So this one cancels with this. So you are left with this pair. This pair is nothing but eta, and this u infinity with this u infinity will become f prime theta prime u infinity eta over 2x. What is left on this side? F prime theta prime. So let us look at this. This is the term. This on u d theta by dx was exactly the same term with a minus sign. So these two will cancel off. Okay, that is why I will be left with energy equation becomes minus f theta prime u infinity by nu x dn by dx is equal to alpha u infinity theta prime double prime over nu x plus 2u infinity over x local Eckert number f double prime of eta the whole square. Now I have to simplify this term dn by dx. So let me just simplify this one. Sorry, we have left out this term. Sorry, this term was left out. I forgot to add that. So left hand side had one more term, u theta dg by dx over g. This was left out. Three terms were there. This was the first. Second and the third term came from the expansion of the v d theta by dy. This term remained as it is, which I didn't touch. Right hand side was these two terms. So I will just write this part as u theta dg by g dx. U theta dg by dx over g. So this is what I have simplified to. Now I have to manipulate these two terms on the left hand side. So let us look at one term one by one. So dg by u theta by g dg by dx minus f of theta prime u infinity by nu x under root dn by dx. This is my remaining LHS. Okay. So what is n? What is n? N was nothing but this one. What is u infinity? U infinity is a function of x. We said u infinity is nothing but cx to the power n. Cx to the power n. So instead of doing something like that, let us just manipulate it a little bit so that we are a little easy. So we will write this as this quantity u infinity over nu x. Okay, so if I multiply and divide by nu x, what would I get? This with this would be u infinity nu x under root divided by nu x. Nothing has changed. What is u infinity nu x under root? This is my n of x. So u theta over g dg by dx minus f theta prime I have multiplied and divided by nu x over nu x, so nothing has changed except that I can write this as n of x over nu x dn by dx. dn by dx. You can write this as dn by dx. And right hand side is nothing but this is still your LHS. And right hand side remains the same, which is alpha u infinity theta double prime by nu x plus 2u infinity x Eckert local f double prime whole square. Okay, so we are just trying to manipulate things so that it is a little easy for us. So it is a little easy for us. So what are we going to say? Now nu over alpha is Prandtl number. Use definitions. Nu over alpha is Prandtl number. This is the first definition that we will use. Then we will manipulate things such that you bring the you multiply both sides by x. That way this x in the denominator is lost. So you multiply both sides by x. So I would get u theta, and actually u is here nothing but u infinity f prime of eta. So this is actually u infinity f prime by g dg by dx minus f theta prime n of x by nu x dn by dx is equal to alpha over nu. This will become Prandtl number u infinity theta double prime by Prandtl number x plus 2u infinity by x local Eckert f double prime squared. So if I multiply both sides by x, I would get u infinity f prime x over g dg by dx plus f theta prime, this is dn by dx into n of x over nu is equal to u infinity theta double prime by Prandtl plus 2u infinity Eckert f double prime squared. I can cancel u infinity throughout, here, here, here. So I would get u infinity. I would get u infinity. So this one, so f prime dg by dx, let us write this now in terms of theta. Dg by dx is as it is, theta x I think is there. So this one is u infinity, there is a theta, so u infinity theta, u theta by g, so u was u infinity f prime, so theta remains as it is, so u infinity f prime theta. So I am left with energy equation becomes theta f prime x by g dg by dx plus f theta prime u infinity dn by dx n of x by nu, this nu should go away. This is nothing but theta double prime by Prandtl number plus 2 Eckert f double prime squared. Eckert. Okay, so I have 2 Eckert theta double prime f prime theta x g dg by dx minus f, sorry here this is minus sign, minus f theta prime dn by dx n of x nu. So let us manipulate this. So u infinity nu x divided by nu u infinity dn by dx f theta prime. This is nothing but, so consider this quantity, this one. This is f theta prime. You get x over nu u infinity dn by dx under root. This is nothing but f theta prime. You multiply both sides by root x, so you would get root of x into root of x divided by u infinity mu x. This is f theta prime x divided by n dn by dx. F theta prime. Therefore, if I use all this together, I get theta f prime x over g dg by dx minus f theta prime x by n dn by dx is equal to theta double prime by Prandtl number plus 2 times local Eckert number f double prime square. Okay, so now we are almost done with the derivation. We are just have a couple of steps left. So I have here x by n dn by dx, f x by n dn by dx. So consider x by n dn by dx. There's a lot of manipulations unfortunately, but we have to do this. So n is u infinity nu x under root. This is nothing but cx to the power m nu x under root. Therefore, dn by dx is equal to under root of c nu d by dx of x to the power m plus 1 by 2, which is nothing but m plus 1 by 2 c nu under root. This is going to be x to the power m minus 1 by 2, right? Derivative of m by 2 plus half is nothing but m by 2 minus half with this thing in front. So this is coming out to be m plus 1 by 2 c nu the root sign x m minus 1 by 2 can be written as, I want to write it just like this. So this is c x to the power m by 2 minus x to the power half, x to the power m by 2 minus x to the power half. So I would like to simplify this a little bit, and I will say this x to the power m by 2 divided by x to the power half. What is this going to be? We will see very quickly. So x, we wrote dn by dx. So x by n dn by dx is nothing but x over nu u infinity root x, and this is m plus 1 by 2 root of c nu x to the power m by 2 and root x. What is this? Root x by root nu. U infinity is cx to the power m. So this is 1 by cx to the power m, m plus 1 by 2 root of c nu x to the power m by 2 divided by root x. Now let us look very carefully here. Root x, take a better one, root x, root c, root nu, x to the power m by 2 in the denominator, x to the power m by 2 in the numerator. This also cancels, and I am left with m plus 1 by 2. That is the beauty of this simplification. So I get energy equation, which was here, becomes, energy equation therefore becomes theta f prime x by g dg by dx minus f theta prime m plus 1 by 2 is equal to theta double prime by Prandtl plus 2 times local Eckert number f double prime squared. And if I do this manipulation, multiply by Prandtl number throughout, and I group the terms a little bit, so I would get theta double prime plus Prandtl number, and bring these two to this side, I would get f theta prime m plus 1 by 2 just as it is, minus f prime theta x by g dg by dx, it is gone on this side, plus 2 local Eckert number f double prime whole square equal to 0. And this, let us put this as a bracketed term, and m plus 1 by 2 f theta prime. This is my simplified ordinary differential equation. If we look at this, this has what? Theta prime, theta double prime, f prime, f double prime, all functions of eta only, right? We have lost our x and y dependency. The only thing where we have x is this one and this quantity. These two terms, if you look carefully, theta double prime, second derivative of theta. F is related to f prime, which was u by u infinity. Theta prime was the temperature gradient with respect to eta, m plus 1 by 2, where m is a constant. This term again f prime theta, this written in bracket and bold red color, and this Eckert number. These are the only two terms which are there additional, and we are going to invoke our golden rule that for similarity to exist, this is very important. For similarity to exist, these terms which are the coefficients or which are in front of these two terms, they necessarily should be independent of eta. So we should have x by g dg by dx is equal to constant, we call this gamma, let us call this gamma, and local Eckert number should also be another constant. These two conditions are necessary conditions. Okay, extremely important to understand that because we are taking viscous dissipation, you can have whatever be the form, but for similarity, for this equation to have a similarity solution, for this to be satisfying similarity condition, the governing equation should lose all the x and y dependency. Where is x here in this term? Where is x here in this term? U infinity x, tw of x. We are not saying, please note here, g is tw of x minus t infinity. We are not saying that this should be constant. Okay, g of x, this is a function of x, right? G of x it is, right? We are not saying that this should be constant. We are not saying Eckert number should be constant. What is Eckert number again? This is local Eckert number is u infinity. That's why I kept writing this way. Half local value divided by Cp Tw local minus T infinity. The variation of this quantity should be independent of x. U infinity can change with respect to x. Tw can change with respect to x. Doesn't matter. Eckert number should be a constant. Same thing here. This is a function of x. So dg by dx times x by g. This need not be a constant, but this bracket whole thing should be a constant. Only then is similarity going to be valid. Okay, so we are not talking of constant TW or constant U infinity. We are saying these two conditions have to be satisfied, and let us now look at one condition. Let us consider dg by g or x by g is equal to gamma, which is implying dg by g is equal to gamma dx by x. If I integrate both sides, I would get log g is equal to gamma log x plus some constant, and we can write this as g is equal to some delta t reference x to the power gamma. The constant can be absorbed in terms of some reference delta t. X to the power gamma times delta t reference is equal to g. What does this give you? It helps me understand that this quantity, for it to lose its dependency of x, what should be the value of gamma? So we don't know what this gamma is. We want to find this out. Local Eckert number is, I have written there, u infinity squared by 2, that is cx to the power m. Cx to the power m is nothing but cx to the power 2m by 2, correct? U infinity is cx to the power m. So u infinity is cx to the power m. Square of that, c squared x to the power 2m divide by 2, and cp as it is, this is your g. So g is nothing but delta t ref x to the power gamma from here. Therefore, I get this as c squared cp delta t ref 2, you keep here as it is, no problem, x to the power 2m minus gamma. This whole thing should be equal to constant. This was my constraint here, right? This was my constraint. So this should be constant. What does that mean? It means that x to the power 2m minus gamma should be equal to 1, which means gamma is equal to 2m. Very, very important condition. We didn't know what gamma was. Now we are saying gamma should be equal to 2m. So if viscous dissipation is there, gamma can take only a value to m for similarity to exist. If viscous dissipation were not there, that is Eckert number went to 0, gamma can take any value if mu phi was tending to 0. Okay, more on this in the next module. After this, we will simplify this equation for the case with u infinity is constant, and do the analysis so that we come back to Reynolds analogy. This is in the next module. Thank you.